Ladies and gentlemen, welcome to Linux from scratch. We're going to be building a Linux from scratch system inside of a VirtualBox. So, you're going to need to know a little bit about VirtualBox and how to set it up. So, we're going to create a VM. And I don't care what I name it. And I'm just going to go ahead and choose my ISO. This is not going to be an in-depth tutorial. It's just going to be a basic guide on how to get your system running with minimal resistance. Okay, when I get into the ISO, all I do is configure the settings real quick. I just turn off well, first of all, I go into the display, go into the resolution, change my resolution to the native resolution. Then I go into power, and I turn off the automatic power saver, and then I go into the screen lock, and I turn that off, and then I go into the time and date and set my time zone. So I got a waiting for cache lock. That's because it's doing automatic updates. if you get that waiting for cache lock, you gotta wait to see the updates ready to install at the top, and then you'll be able to get your stuff. And what I'm installing is SSH and NetTools. So I set a password for the user and I retrieve my IP. Now I'm going to enter an SSH. So I've entered SSH with a PowerShell on Windows because I use Windows to stream. And so I'll be interfacing with this shell through this PowerShell. Now let's go to Linux from scratch. And this is Linux from scratch version 13.0, System D version, published March 5th, 2026. And what I'm going to do is skip right down to the host system requirements on chapters 2, page 2. This is where we begin to run the commands. My VDI I set up for 100 gigs. We want GPT. And the first partition will be a 512 megabyte. The type will be an EFI system. The next one will be a swap. And that type will be a Linux swap. The next one will be my remainder size. Right. And quit. Then we'll write the file systems. Then I point sh to bash using the ln and install some prerequisite software for LFS. And what I got was M4, Gawk, Bison, Flex, Automake, Auto Seal and F, Build Essential, and Text Info. Okay, so now let's go into the book. I'm going to run this command to see if we can move forward in the book. Everything checks out okay, so we set up our ISO right. And now we're going to go into chapters 2, page 6, and set our environment variable. This points to the root file system. So SDA1 is your EFI, SDA2 is your swap, and SDA3 is your root file system. Now let's go ahead and mount the root file system. Now additionally, we're going to make sure the LFS directory is owned by root. And we're going to enable the swap. Now to check, you're going to see if you run an lsblk-f, you'll see the swaps enabled and SDA3s mounted on MNT-LFS. And additionally, you can df-a capital H on your variable, and it will show you SDA3s mounted on MNT-LFS with 96 gigs available. Now moving into chapters 3, we're going to create sources. This directory houses our software. And we're going to modify sources permissions to make sure we can access it with an unprivileged user, LFS, that we create in chapters 4, for chapters 5 and 6, even though sources is owned by root. Now we got to gather up the software. So what I'm going to do is duplicate a tab, go all the way to the beginning, and go to the website mirrors. You can do this for stable, but you can't for development. I wish they had the development mirrors. That'd be alright. And we got to go over and get our firmware. I put these links in the description. And this is going to take some time. Okay, if you do a listing on your sources directory, you'll have two tar files, your Linux firmware and your LFS packages. Extract your packages. And move them back up into sources. Now we're going to go back to the book and run this MD5 sum command. If they check out okay, you're able to move on. Okay, so I removed wgetlist, MD5 sums, checked out sh, 13.0 directory, the LFS packages 13.0 tar file, and the lost and found. Okay, so let's go ahead and make sure everything in sources is owned by root. And then we'll move into chapters 4. So now we're going to set up the first forms of our file system. Tools is a temporary directory that we're going to create for the cross compiler, the cross assembler, and linker. Now going into chapters 4, page 3, we'll set up the LFS user for chapters 5 and 6 for cross compilation. And we'll set a password and change some of the ownership of our directory layout over to LFS. So doing an ls-la on your variable, you'll see your file system that you just created on your variable. And what you're going to see is everything owned by root, and etc, lib64, tools, usr, and var are owned by LFS. Sources is owned by root, but it has read-write executable permissions for owner, group, and other with the T for a sticky bit. Now let's go ahead and SU in the LFS. And now that we're the LFS user, we can go into page 4 of chapters 4 and set up the bash profile and the bash RC. And these two files are going to set up an interactive non-login shell. The bash RC has all the variables for chapters 5 and 6. And additionally, we're going to go down to the bottom of the page and run this make flag. And then we're going to go back up and we're going to exit out of the LFS user back into root. And we're going to run this important command. And what this does is clean up the environment a little bit more. Now we're going to immediately SU back into LFS. And what you see on the command prompt is just LFS tilde $. Run an env. You'll see your environment is set up. You got things like your LFS TGT, your LC all POSIX, your environment variable, MNT and LFS USR share config.site is found. MNT LFS tools is ahead of the path. You got your make flag set. Everything is good to go. Now we can go into chapters 5. Extract bin utils, create a build directory, cd into it, configure, build, and install. And bin utilities pass 1 is the cross assembler and linker. There are 2 linkers in this project. There's a dynamic linker, or also known as loader, and the standard linker. The standard linker links object code at build time, and the dynamic linker links libraries to the executable at runtime. And we need bin utils for the assembler and linker because it's a dependency of the cross compiler that we're going to build that's going to cross compile chapter 6. Okay, so now we're on the cross compiler. Let's go ahead and extract the math libraries. These are dependencies for GCC. We don't have them system-wide yet, so we got to build them with GCC. And now we got to make sure lib is the default directory for 64-bit libraries. And then we'll go ahead and create build cd into it. And we'll build this. I'm going to time this. I don't know how long it's going to take. This is a compiler in VirtualBox. Boom. And I think it may take between 7 and 9 minutes. Might take like 11 minutes, I might be lying. So run the make install, and then we got to create the limits file down at the bottom. Then we move into the Linux API. So you're going to run make mr proper, and then you're going to extract the API. And that's the API we're going to be building chapter 6 again. So now we're going to get the standard library. We can run this at any time. These are compatibility symlinks. Now we got to go ahead and get into glibc. We're going to run a patch to fix an FHS issue. Then we're going to create build and cd into it. We want to make sure ld config and sln are installed in the appropriate directory. And we're going to just build the standard library, glibc. Okay, so for the remainder of chapters 5 and throughout chapter 6, you'll see this dester LFS, and that's going to point the install into MNT LFS. It's very important that that dester gets put in the install. It won't change until chapter 7 when we enter change root. Okay, now what we're gonna do is run this sed script, and this will fix the hard-coded path in the executable loader in LDD script. And if you want to run your test, run every command, follow the output, and you should get the output that's in the book. Now we're on to libstdc++. This is the C++ libraries. It is a part of GCC. Okay, so now we're going to create a build directory, cd into it, and configure this C++ library. We'll make install with the dester, and then at the end after the install, we will remove some archive files that could be potentially harmful to the cross compilation. We will remove them through chapters 6, and chapters 7 and 8. They're not really that big of a deal. Okay, so we're done with chapters 5. Now we're going into chapters 6. So what we did to recap, okay, we went through chapters 2, did all that. So what we did in chapters 2 was prepare the host system. And so we ran the host system requirement script, told us we could move forward in the book. And then we went into setting the LFS variable for the rest of chapters 3 and 4. And then we mounted the partition, we set up the swap. Then we went into chapters 3. We gathered up all the tar files and the Linux firmware, all the stuff we needed to build our LFS system. Then we went into chapters 4. We did some final preparations. We set up the file system that we're going to be building our LFS system in. We set up the LFS user that we're going to be cross-compiling this part. Now that we're on this part, we're going to be cross-compiling chapter 6. And then we went into chapters 5. We built the cross-compiler and cross-assembler, which then in turn built the Linux API, the glibc, and the C++ libraries. Now we're going into chapter 6 and building all the rest of our utilities and rebuilding the cross-compiler and assembler. But this is actually, well, let's get into that later. But what we're doing now here is smashing all this against Linux, glibc, and libstdc++. And that gives us a very basic framework of a system that will run in change root. So we can change root into our system, this system that we just built, and build further. Okay? And what that does is reassure our isolation from this system, because we don't want nothing to do with Debian in our LFS, because if we do and we remove this Debian at the end, we're going to have issues if it's looking for it. And so going back to binutils and GCC and pass2, we rebuild this because, well, we need a GCC to build in change root, right? This one is not meant to build in change root. This one is meant to build a compiler that can run in change root. So that's what we're doing. And obviously we need all the rest of these utilities, well, because when we're in change root, we need to be able to tar our files. We need to be able to run sed scripts. It just makes sense. And so this compiler and pass 1 of binutils and GCC takes a back seat once we get this one built. And then we go forth into chapters 7 and 8 and use this compiler to build in change root. And what change root is pretty much booting into our LFS system, this one, without grub. And all we're using is the Debian kernel to get change root. Which explains why we gotta do so much. And it's funny because everything up to chapters 8, but not including chapters 8, is just prep work for chapters 8. Chapters 8 is actually our final system. This is what, all this software right here in chapters 8 is what we're going to be running once we get booted into our system. Not this stuff. This stuff is built in USR, yes. So it is the very first forms of our system. We just rebuild everything, and plus all kinds of other stuff in chapters 8. So yeah, we have to rebuild GCC again in chapters 8, and we are going to be bootstrapping it because we might be going into Beyond Linux from scratch someday with this tutorial. And for me personally, I just build it for robustness and fluency. I want to make sure this compiler never breaks. And if it can bootstrap, I'm pretty satisfied with it. So that's how I look with that. But Unfortunately, because I'm in a VirtualBox, this compiler may take up to 2 hours to bootstrap. But once we get done with that, we're pretty much on our home stretch into getting our system running. Before we get that far, we have to get this chapter 6 built so we can change root. With that said, I'm going to be taking a quick 5-minute break because we are now in chapter 6 and we're going to barbarically tear through chapter 6.
You're the one I need. I wanna hold you 'cause I need you by my side. 'Cause you're all I want. I got what you need. I wanna hold you 'cause I need you by my side. You're the one I want. You're the one I need. I wanna hold you 'cause I need you by my side. 'Cause you're all I want. I got what you need. I wanna hold you 'cause I need you by my side. 'Cause you're what I need. 'Cause you're what I need. Cause I wanna need. Cause I wanna need.
Okay, so we're on chapter 6. Let's get it done. M4 is a macro processor. Shout out to my buddy Ben. He's in the chat. Go talk to him if you guys want somebody to talk to. Okay, so M4 is done. Now we're on Ncurses. Ncurses deals with terminal libraries. It deals with character screens. And we need it for the kernel. Make menu config. So we got to build tick inside of tools. We're not installing it. There is no install here. It's just the build. And that's for the use of it later on by the system. Now we got to build the libraries. And we just run make, and then here's the install. And then we got to run all this junk to set up the wide character libraries. And then we're on the bash, and bash obviously is the born again shell. It's a shell where our system's going to use bash. Then we got the make, install, and then we got to point sh to bash. This is mntlfs bin sh. So this is for our LFS system. We did do this at the very beginning of the project. The one in the system. This system. Actually right here. Oh, actually it's not because I didn't run it in that. And I am removing all these extracted files as I go. I want to keep it clean sources. And now we're on core utilities, and this is just a tar file full of small programs that never got their own tar file. And there's a lot of them. I'll show you some of them when we get into chapters 8 because we're rebuilding core utilities anyway. Okay, so this is a make install, and then we gotta install change root into sbin and fix up its man page. Okay, now diff utilities, we gotta tell the difference between files and directories. Okay, now we're gonna just get it installed and move into file. File gives you give an extension. You gotta know the difference between an MP3 and an MP4. So yeah, at the end of the day, we get file. And this is kind of like ncurses. We gotta build file. It's a version check with configure. I'm pretty sure. And so we got to build the same version of file that we're building here on the build host, which is this. And then once that's done, we go ahead and configure file. And then we'll go ahead and make. With the file program we just built. And remove an archive file. Okay, find utilities. Find utilities finds whatever given input that you give it, whatever file you give it. Recursively searches a directory tree or uses a locate command through a database to find your given input. And so why do we need this? I'm gonna assume just like this that this is a dependency of something else we're building. And so we can't get whatever that is if we don't have find utilities. And besides, they're preparing us for Beyond Linux from scratch. So you're going to need it all anyway. So we're just going to have to swallow the big pill and get find utilities. A lot of people may ask, why do we need so much software when we build the system? It's really, truly, I think, because they are preparing you for other projects that are variations of Linux from scratch. So they just want to make sure you have a robust, fluent system that runs. If you are a developer building Linux from scratch, like the elitists that build it, they're gonna install find utilities. Okay, now we're on Gawk. Gawk is GNU Awk. Gawk is a program that manipulates text files. So yeah, you have a file, you're writing on a program, you get a source file, okay? You want to go in there and change something in the file, but you don't want to have to, if it's multiple things, if you got, say, a line that has 300 lines of code and you have 20 dogs and you want to change 20 dogs in that file to 20 cats, you have two options. Go in there and recursively do it yourself manually, or program a program that goes in there and does it automatically. Gawk is an amazing program. It can think for itself. It can do mathematics and stuff. It is a quite interesting program. Set is another one that does essentially the same thing. It uses regular expressions. It's a little bit more complicated to understand the syntax with set, I do believe, but at the end of the day, set is an amazing program. We will get it in this project, but let's not talk too much about a program we're not on right now. We're going to get Gawk because Gawk is definitely a very important package to Linux developers, and it's probably a dependency of something in the system. You can use it with the pipe command and pipe different. This is kind of like um, a very universal program that can be used with pipes. Things like find, grep. And we'll just make install and move on to grep. Grep is a program that recursively searches through a file so you don't have to. This is also used with pipes. It's used with find a lot. Um, and so at the end of the day, uh, you use it with Gawk. If you want to grep a file, you go in. You can say you run grep. You want to go into a file. You want to know the exact line number, where it's at, all the information about what you're looking for. There are switches that you can run for that. Um, and then you can't modify the file, and that's the difference. You're just looking. And then we got gzip. Gzip is compression. It's just probably yields the worst compression, but is very nice to use when you just want something on a whim. Oh, it's one of the first ones that were created. It's GNU Zip. Um, Other ones have been formed and other ones have been relegated. It's just another compression decompression software that we're gonna get. Uh, it is still used quite frequently in tarring files and stuff, and as a matter of fact, this GZ is the extension, and with some of our files in our directory, in our sources directory, are gzipped. So we're gonna need it anyway. Me personally, I like using XZ. I think XZ is my favorite in my opinion because it yields the best compression. But this is like it's fast, it doesn't take long to compress with gzip. It's almost merely instantly. So yeah, that's where like with good compression comes more time. So it's really about how much time do you want to wait to compress a file. It's like, do you want to go to the Walgreens or do you want to go to the Hannaford? Because you're going to be all day at Hannaford, and Walgreens you'll be in and out. Convenience cats. Okay, let's get gzip. Okay, Make is a build automation tool. It is used with GCC, and this is very important because it does our build for us. Would you rather go in? Well, I'm going to make this very clear once this is done. This is a build directory. Would you like to come in here and run GCC manually on every single one of these and connect the dots? Who would? I'm not gonna, because that's pure madness. So what we do is build a build automation tool that does all this for us. So it's like a police officer in the street directing traffic, and that's what this is pretty much doing. And we actually use it every time we build. It's right here. And so we're able to run make now because we built it on this. We ran build essential. This make is meant to run in our LFS. Got to remember, we're building this to change root into. Okay, so now we're going to go ahead and get patch. Patch explains itself. It's got syntaxes and stuff from other everything's kind of glued together here. So yeah, I don't know what it uses to make. It's actually created by the diff program right here. So yeah, that's what does all that stuff. And what it does, and we actually run it in the book. You'll see the patch command every once in a while. That's this. So yeah, that's why we gotta have this. It's a patch that runs and creates the patch files for devs. that are trying to get upstream stuff going. Okay, now we're on the sed. Sed is like Gawk. It goes into a file and it's input output. You got to think input output, on off input output. That's how it all works. So you give it input, it gives you output, right? So if you want to change patterns in the text or something, it doesn't do math. It can't think. It's not an engine like Gawk. But Sed is just a simple program that goes in, finds the patterns you're giving it, and changes it. So once again, people will use Sed to modify make files and whatever files they want when they're in development, trying to change bugs and fix bugs. They may run a Sed script on a software package to change a make file, and that's what, if you will see them throughout the book all over the place, because they're using them to change the make files more than likely, so the software builds. So that's what this does. It's a stream editor, if anybody knows what that is. But what it is it just goes in and changes patterns in a text file. You got to think, what is set. I mean, well, look at the command you're running in the book, right? Okay, so set is done. Now we're on tar, and these are all tar files. So what this is, it's an archiver that tars archives. So you've got a collection of stuff, you tar it up, compress it, send it on its way. And that this is used throughout the book, all over the place, because you gotta extract your files. So yeah, at the end of the day, we definitely gotta have tar. So let's get it. And so, yeah, once again, like make, this is built for the LFS system. Okay, now XZ is another compression decompression, my favorite. Yields the best in compression in my book. Just because of the algorithm. It's the algorithm it uses. I love it. Okay, let's make install, and then we will remove this archive file at the bottom. Okay, now for the journey through bin utils and GCC again. These are the last two packages in chapter 6. And so we got to make sure there's no linking to the host system. Then we're going to create build and CD into it. Let's go ahead and build bin utils. So remember, the GCC we built the first time is building this bin utils in GCC. These are going to run in our change root. And down at the bottom, we got to remove some archive files and some other unnecessary static libraries. Now we're on to GCC. Okay, let's do it. We're going to go ahead and extract the math libraries again. Then we're going to go ahead and run the case command again for the 64-bit libraries to be installed in lib. Now we got an additional sed script for POSIX thread support. This is very important. Build CD into it, and then let's go ahead and attack this. And I'm going to time this too. This is unfortunate because it's going to take about 15 minutes or so. I don't even know, 15, 16 minutes maybe. So yeah, it might take a minute, 14 to 16 minutes. But if you get it built, you definitely can move on in the book, so stay tuned. Okay, so run the install, and then we gotta point CC to GCC at the bottom with a symbolic link. Okay, so yes, if you've made it this far, congratulations. Okay, good deal. Let's just enter Sharut real quick. We'll change ownership. So, do you remember? We changed at the beginning of the book, we changed DTC, lib64, tools, USR, and var over to LFS so we could build with the LFS user. Now we run this command and change it back over to root. If you have an issue with that, just make sure your variable set as root. Now doing an LSLA on the variable, you'll see everything's owned by root. Now we gotta create dev proxys and run for change root. And then we gotta mount bind DEV to MNTLFS DEV. Then we're gonna prepare our virtual kernel. That's a part of change root, and at the bottom we got this if command. And in that if command is another mount command. If you ever gotta remount this kernel, okay, run this mount command, but don't run the entire if command. Now we're gonna enter change root. And there it is. We have I have no name. So we entered change root. That's good. We're able to move on, but I am most certainly going to end it here because I think at the end of the day we've made a lot of progress, and I want to give you a break. I need a break. We'll come back a little bit later and do a part 2. Get through chapters 8. So to recap what we did real quick with this, I don't even have to. I'm pretty sure you guys know what we're doing at this point in time. Okay, so yeah, we're going to pick up on creating these directories in chapters 7-5. And so with that said, just close out of your PowerShell, your Firefox can go down or whatever you got. Go over to your VM. And now power this down by hitting this X right here. And save the machine state. This is not meant to be powered down until it's running. So I got an error on it. It wasn't able to save. You probably won't have that issue. I think I shrank the screen down too small. So in the next video, I will show you guys how to reset up the virtual kernel. That's about it. Mount Chroot. But either which way, you're able to move on with your system like you never even did anything with Linux. That's the beauty of virtualization software. The beauty of virtualization software is that you can run systems inside a system. Okay? And anybody can do this because it's virtual. It's free, doesn't cost anything. And so, thanks for watching. If you want to follow me through chapter 7 and through chapters 8 and the next stream, you must join me in the next stream. So like, subscribe, and keep dreaming big Linux.